Okay, so this is part 2 to the 7-2 Algebra 1, 7-2. So one thing I want to point out on 7-1 worksheet, it says if there is not exactly one solution, state whether it has no solution or infinitely many solutions. I just want to go real quick what that means. All right, so let's say you solve your equation, your system of equations, and you get something like y equals y. So that would be an infinite, oops, sorry, y'all. That would be an infinite number of solutions. Okay, well, whatever variable you have, if you get that variable equals itself, then that means that's an infinite number of solutions. If you get something like 3 equals 4, which 3 does not equal 4, then this will be an example of no solution. Three does not equal 4. So this will be no solution. Anything that's just an example numbers. If you get anything like that where you get a number does not equal a number, that will be no solution. Okay, so now we're going to get into the second page of 7-2. And this is going to be a little different than the other page. So the key thing for working out these problems is picking out so basically what we're going to be doing is creating equations from the word problems. And so to create the system of equations to write it correctly, you have to determine the elements that are being discussed in the word problem. So in this question, it says, how much of a 10% saline solution should you mix? Thank you. Should you mix with a 20% saline solution to obtain 1,000 milliliters of a 12% saline solution? So the 10% saline solution is one item in this problem, and then the 20% saline solution is the second item. And then the mix we're trying to get is a 12% saline solution, and we want that to be a total of 1,000 milliliters. So the the two elements in this problem is going to be the amounts of each solution and the percentage of saline in each solution. So one equation will represent the total amount, which would be the milliliters, and one equation will represent the percent of saline that each solution has. So once again, the first element is going to be the amount of the solution. And then the other element is going to be the percent of saline within each solution. So for the amounts, we didn't know, they didn't give us the total amounts for the 10% solution and the 20% solution. So you can see in the problem, they didn't give us those amounts. We don't know those amounts. So we have to represent those by variables. So the 10% saline solution, we'll just represent that with X. And the 20% saline solution, we'll represent that with Y. So we'll have x plus y because these are the two solutions we're combining. And we know that they're going to wind up equaling 1,000 milliliters in total based off our word problem. That's our goal, to get 1,000 milliliters. So for the second solution, our second solution represents the percentage of saline within each one. So we have the first solution of 10%, so that's going to be 0.10 times x, because it's 10% of the total milliliters, and then 0.20 times y, and then 0.12 times 1,000, which was our final that we're trying to reach. Just double checking that. All right, so it's going to be 0.12 times 1,000. So these are our two equations for our system of equations. And now we can use substitution to solve our x and y values. As you can see, we'll have to do like we did on the example B on the first page, and we'll have to take one of these equations and solve for one of the variables before we can substitute. All right, so let's go ahead and do that. So we can take the x plus y equals 1,000, and let's solve for, I think I'm going to do, so let's solve for x. Nope, we'll solve for y. So we'll subtract x from both sides, and we get y equals 1,000 minus x. So anywhere we see y in our equations, that means we can replace it with 1,000 minus x. So we'll go ahead and rewrite this equation at the top as y equals 1,000 minus x. It's the same thing. And then now we can do our substitution. All right, so we'll plug this into our other equation, and I'll just knock off the zeros since you don't need those for that particular number. So we can just do 0.1x plus 0.2, and just for space wise, we'll just take them off. So 0.1x plus 2 times 1,000 minus x, because we're substituting y for 1,000 minus x because it's equal to y. And then I'll just go ahead and do that math. 0.12 times 1,000 is going to be 120. All right, so now we distribute our 0.2 throughout the parentheses. Sorry. So once again, we're going to distribute 0.2. So we'll do 0.2 times 1,000, which is going to be 200. And then 0.2 times negative x is going to be negative 0.2x. We're going to make sure we're carrying our negative and our decimals, not just getting rid of stuff. So now we have 0.x plus 200 minus 0.2x equals 120. So we're going to combine like terms. So 0.1 minus 0.2 is negative 0.1. So we have negative 0.1x plus 200 equals 120. And let's just erase some of this so we can have some more room to work with. rewrite this. I'm just moving this up, rewriting that. So we combine like terms and we're left with negative 0.1x plus 200 equals 120. And then we're going to subtract 200 from both sides. And we're left with 0.1x, negative 0.1x equals negative 80. Then we're going to divide by negative 0.1. And so negative 80 divided by negative 0.1, it's going to yield a positive answer, and it's going to be 800. I'm just going to double check that with the calculator. 80 divided by negative 80 divided by negative 0.1. 800. So x is equal to 800. And remember we said our 10% saline solution was represented by x. So that means we'll have 800 milliliters of the 10% saline solution. And now we can plug that into our other equation to see what the y is, or to see how much of the 20% saline solution we'll have. So that's y equals 1,000 minus x, or y equals 1,000 minus 800. So y equals 200. So again, our 10% saline solution was represented by x, so that means 800 milliliters of that is what we need. And our 20% saline solution was represented by y, so that means we need 200 milliliters of that solution.